Okay, so in this video, I'm going to go over how to do problems from practice test 1, and we're going to do questions 7 through 11. So the first question is, what is the percentage of carbon found in tin 2 acetate? So this is a percent composition problem. So we're going to have part over whole, and the part we're looking for is the carbon, and the whole is going to be the whole tin 2 acetate. So we need the formula for it. Now it's tin 2, so it's going to be SN plus 2. And then acetate is C2H3O2 minus 1. So we're going to need 2 acetates to balance this out. So the formula is going to be, okay, now let's put that under here. And then we times it by 100. So now we have our problem set up. The next thing we need to do is we need to figure out the molecular mass of everything. So let's go through this large problem first to figure it out. So tin is 118.71, carbon's 12.01, and we're going to multiply it by 4 here. The reason we're going with 4 is because we have 2 here and then 2 here. So we're going to multiply these together. So that's where we get the 4. If you take a look at the hydrogen, hydrogen's 1.01. And there's 3 here, but then there's another 2, so we distribute this and it multiplies, so it's going to be times 6. And then the oxygen is going to be 16.00, and then there's 2 here, 2 on the outside, that's going to give us times 4. Okay, so once we do all of this math, we're going to get a molecular mass of 236.81 grams per mole. And then in our class, we're just rounding to 2 decimal places for all of our molecular masses. All right, that's what goes on the bottom here. And then on the top is just the carbon part of it. So that's this part, the 12.01 times 4, which is going to give us 48.04 grams per mole. And we're going to time this by 100. Percent is the unit. Don't type that in your calculator. Just times it by 100. And like I said, it's our units. So that's what we're going to end up with. Okay, and once you plug this in your calculator, you should get 20.29% carbon. There's 4 sig figs here because this has 4 sig figs. This is 5 sig figs. And because we're dividing, we're going to go with the least number of sig figs. All right, so there we go. Okay, in this problem, it says, given the percent composition of all of this, find the empirical formula. Okay, so now we need to figure out the empirical formula. And there are 4 steps that you need to do, or at least 3 of them that you need to do to solve these kinds of problems. The first one is go from percent to grams. And we can just write down these numbers in grams because we're going to pretend we have a 100-gram sample of it. And so if we have 100 grams of it, each of the percentages would just equal the amount in grams. Okay, so now we did the first step. The second step is we're going to go from grams to moles. So here, let's do that. Okay, so to do each of these, it's going to have the molecular mass on the bottom. So sodium is 22.99 grams Na. 1 mole is going to go on the top. Do the same thing for the other 2. Okay, so now that we have all of these, we do the math, and we'll get... Now, the third step is divide by the smallest number. So out of these 3 numbers, this is going to be the smallest one. I'm going to change the color to make it easier to see. Okay, so now we have these, and we're dividing them all by the smallest one. The middle one is going to be 1 because it's the same number being divided by itself, and the other ones are going to be 3. Now, these numbers have to be whole numbers or they need to be close to something that's a multiple. So it could be like 3.25, or it could be 3.5, something like that, that you can easily multiply by a whole number. And so if you have those kind of problems where it ends up being a decimal, then you have to multiply by some kind of integer to get a whole number out of it. This problem worked well, so we just have to take these numbers and then know what to do with these numbers. And what you would do is just write out NA, so you write down the first thing, NA, and then there's 3. So the 3 goes down here, it's your subscript. The next one is P, so the phosphorus goes there, and there's only one of them, so you just put a P. And then the O is another 3. So then we end up with this right here. Okay, number 9, it says find the molecular formula for the compound with a molecular mass of 186 grams per mole and an empirical formula of that. Okay, so the first thing you need to do is you need to figure out the molecular mass for this empirical formula. So nitrogen is 14.01, oxygen is 16.00 times 3. So when we do the math for this, we're going to end up with about 62.01 grams per mole. And notice that this is the number that they gave you, okay? So the problem for this is whatever they give you, or the molecular formula mass, or the molecular mass is going to go on the top, and the empirical formula mass is going to be on the bottom. So the bigger number that they gave you goes on top. Sometimes the number they give you is the same as what you calculate. Then it doesn't matter which goes on top technically, because you'll get the same answer. But for this one, the molecular mass is on top. It's bigger, 62.01 grams per mole. It's on the bottom. The bigger number should always be on top, okay? If it's the other way around, something weird has happened with your problem. Okay, so we do this. We get 3, all right? Now you have to distribute this 3 by what they gave you for the empirical formula. So it's going to be 3 times the N and then 3 times the O. So it's going to be N3 and then O9. And that's going to be the molecular formula. Okay, number 10. Now this is a combo of the last two. So the first thing you have to do is find the empirical formula, and then you have to find the molecular formula. So if you recall, the first thing we did was we converted percentages to grams. So 48.0, now it's going to be grams of carbon. 9.33 grams of hydrogen. 42.66 grams of oxygen. And now we're going to convert these to moles. Okay, so when we do these this division, we get these numbers, and these are the moles for each of them. And then we divide by the smallest number. In this case, it's 2.666. All right, and that should give us carbon about 1.5. Hydrogen looks like about, it's close to 3.5. It's a little lower, but that's okay. We're going to have to round it to something that we can multiply it by. And then oxygen is going to be 1. Okay. So what this actually means is now you have C 1.5, H 3.5, and then O. Now, this is where you have to do that final step. And so we have to multiply it by some whole number integer to make these whole numbers. So if we multiply them by 2, that should do it. Now, if you don't know what to do, like what to multiply it by, start with 2 and then multiply them and see if you get whole numbers. Then try 3 and then 4 and then 5. You should eventually get them to be whole numbers, and it shouldn't take you a while to do it. It should just take a few tries, all right? Because again, you're looking for something that's either ends in like a quarter, a half, or like thirds, or something like those. That's usually what they end up being, all right? Okay, so let's multiply these by 2, and that's going to give us C3 C3H7O. Don't forget you have to multiply this by 2 as well. O2. So that's going to be our empirical formula. And that is A. A was figure out the empirical formula. Okay, the next thing we have to do is now we have to look, all right, they gave us a molecular mass of 300 grams per mole. And so now we have to figure out, the molecular formula from this. So we need to take these numbers and figure out the molecular mass of the empirical formula. So once we do that, we will come up with 75.10 grams per mole. Okay. And again, the bigger number goes on top, so we'll put 300.0 grams per mole. Also, the molecular mass goes on top as well, so it all works out. And then we divide these two, and we'll get 4. And then with that 4, same as before, C3H7O2. We're going to multiply these all out, so we'll get C is going to be 12 because 4 times 3. We're going to get H is going to be 28, which is a big number, but that's okay. 4 times 7, we get 28. And then oxygen is going to be 4 times 2, which is going to give us 8, and that's going to be our molecular formula. And that's going to be B. Okay, so we figured out number 10. Long one, but we got it. All right, and then finally we have 11. So 11 is pretty similar to 10. So we have a couple interesting things here first. It does say find the empirical formula and then find the molecular formula. An interesting thing, though, is they didn't give us percentages, which is fine. That means they did the first step for you, all right? So they've already converted it from percent to grams. So let's just use these numbers, and then we move on to the next step, which is just convert them into moles. Okay, so we converted them to moles. We get these numbers. Next thing we do is we divide by the smallest number. That'll give us 1 for the oxygen. Give us about 6, looks like, for the hydrogen, and then carbon, it looks like about 2. So what this means is the empirical formula is C2H6O. All right, so that's empirical formula, and that is A. Okay, B, it says find the molecular formula, and they gave us that mass there. So we need to figure out the molecular mass of this, and it happens to be 46.08 grams per mole. Okay, we'll put that 138 on top that they gave us. It's going to equal something very close to 3, so we're going to go with 3. It doesn't have to be perfect. It just has to be a whole number, all right? So then we take that 3, and then we have to distribute it from our empirical formula. And that'll give us C6. Oop, I forgot the C. C6 H18O3. And that's the molecular formula, which is B. All right, there we go. Awesome.